So we need to find the derivative of the given function. So what we do before finding the derivative, we are going to separate the terms in the numerator. So that means we can rewrite it as 2x squared divided by x. So that will be the first term. The second term will be thrice x over x. And the third term, which is 4 over x. Now further simplifying it, we get 2x squared over x will be simply x. The x and x from the numerator gets cancelled out. Similarly, 1x from both the numerator and the denominator of the second term cancels out, leaving us with 3. Then we have 4 over x. What we're going to do is we're going to take the x from the denominator to the numerator, and that will become 4 times x raised to the power of -1. Now we find out the derivative. So we have d over dx of twice x plus 3 plus 4 x raised to the power of -1, which will be equals to 2 times 2 being a constant, we have taken it out of the derivative, 2 times the derivative of x plus derivative of the constant 3 plus 4 times the derivative of x raised to the power of -1. So this will be equals to 2 times the derivative of x, which is 1, plus the derivative of a constant is 0, plus 4 times the derivative of x raised to the power of -1, which will be -1 times x raised to the power of -1 minus 1. So we'll have finally 3 minus 4 times x raised to the power of -2. So this is going to be the derivative of our given function. Let's move on to the next question. So we need to find the derivative of the given function. So we begin by first simplifying the expression. We are going to multiply the two terms in the numerator. So we have x cubed multiplied to x minus 2 plus 1 multiplied to x minus 2 divided by x squared. So we have x squared times x, which will be x raised to the power of 4 minus 2x cubed plus x minus 2 divided by x squared. Now we divide each term by x squared, so that will give us x raised to the power of 4 over x squared minus 2x cubed over x squared plus x over x squared minus 2 over x squared. So we have x raised to the power of 4 divided by x squared, so we'll have x raised to the power of 4 minus 2. So we're combining the exponents. Minus 2 times x raised to the power of 3 minus 2 plus x raised to the power of 1 minus 2 minus of 2 times x raised to the power of -2, which will be equals to x squared minus 2x plus x raised to the power of -1 plus minus 2 times x raised to the power of -2. So now we're going to determine the derivative. So we have the derivative of the first term, which is x squared, minus 2 times the derivative of the second term, x, plus the derivative of x raised to the power of -1 minus 2 times the derivative of x raised to the power of -2, which is equals to 2 times x raised to the power of 2 minus 1 minus 2 times x raised to the power of 1 minus 1, since the exponent of x here is 1, minus 1 times x raised to the power of -1 minus 1 minus 2 times -2 times x raised to the power of -2 minus 1. So we have 2x minus 2, because we have x raised to the power of 0, so that will be 1, minus x raised to the power of -2 plus 4 times x raised to the power of -3. So this is going to be the derivative of the given function. Let's move on to the next question. So we have to determine the derivative of the given function. So we begin by separating the terms in the numerator. So we have a times cosine of x divided by sine of x plus b times sine of x divided by cosine of x. This is sine of x. Sine of x divided by sine of x plus c over sine of x. Now, the ratio, the sine of x over sine of x is simply the cotangent function. So we have cot of x plus b, the sine x gets cancelled, plus c. Now we have 1 over sine x, c times 1 over sine x. So 1 over sine x is simply equals to the cosecant function. So we're cosec x. Now we're going to determine the derivative. So we're going to find the derivative of each of the term. So that will be finding the derivative of our given function, which will be d over dx of a cot x plus b plus c cosec x. So we will get a is a constant, so we take it out of the derivative. So we have d over dx of cotangent of x plus d over dx of b plus c is a constant, so we have taken it out of the derivative. So we have d over dx of cosecant x. Now a times the co-derivative of the cotangent function is negative cosec square x plus the derivative of the constant is 0, so we have plus c times the derivative of cosec x. So the derivative of the cosec x is negative cosec x times cot of x. So this is the derivative of the given function. Let's move on to the next question. So here we have to determine the derivative of the given function. Let's apply the derivative to each of the term individually. So we have 2 times the derivative of secant of x plus 3 times the derivative of cotangent of x minus 4 times the derivative of tangent function, which will be equals to 2 times. So the derivative of the secant function is secant x times tangent of x plus 3 times the derivative of the cotangent function, which is negative cosecant squared x minus 4 times the derivative of the tangent function, which is secant squared x. So our final answer will be 2 times secant x times tangent of x minus 3 times cosecant squared x minus 4 times the secant squared x. So this is the derivative of the given function. Let's move on to the next question. So here we need to find the derivative of the given function. So let us begin by first simplifying our given function. So we have 1 over sine x in the first term. So that is simply cosec of x, because cosec of x is the reciprocal of the sine function, plus 2 raised to the power of x plus 3. So what we can do, we can separate it as 2 raised to the power of x times 2 raised to the power of 3 plus 4 divided by, we have log of 3 with base of x. So here what we're going to do, we're going to apply the property of logarithm, that log of a to the base of b is simply equals to the natural log of a divided by the natural log of b. So we have the natural log of 3 divided by the natural log of x, which is going to go to the numerator. So we have 4 natural log of x divided by log of 3. Now we are going to find the derivative of our given function. So we have the d over dx of cosec x plus 2 raised to the power of 3 is 8. So we have 8 times 2 raised to the power of x plus 4 over natural log of 3 times the natural log of x. So this will be equals to the derivative of the cosec function plus 8 being a constant, we can pull it out of the derivative. 8 times the derivative of 2 raised to the power of x plus, pulling out the constant, we have 4 over log of 3 times the derivative of logarithm of x, which will be equals to the So the derivative of the cosec function is simply negative cosec x times cotangent of x plus 8 times the derivative of 2 raised to the power of x. So that will be 2 raised to the power of x times the natural log of 2 plus 4 over log of 3 times the natural log of x, which is simply going to be 1 over x. So this is going to be the derivative of our given function. Let's move on to the next question. So we need to determine the derivative of the given function. So let us begin by first multiplying the given function in the numerator. So we have x multiplied to 2x squared minus 1 plus 5 multiplied to 2x squared minus 1 whole divided by x. So we have 2 times x times 2x squared, so that will be 2x cubed minus x plus 5 times 2x squared will be 10x squared minus 5 whole divided by x. So now we're going to divide each of the term in the numerator by x, so that will give us 2x squared minus 1 plus 10x minus 5 over x. Now we will find the derivative of this particular function. So we have d over dx of 2x squared minus 1 plus 10x minus 5 times, so we have 1 over x, so that can be also written as x raised to the power of negative 1. So that will give us 2 times the derivative of x squared minus the derivative of the constant function 1 plus 10 times the derivative of x minus 5 times the derivative of x raised to the power of negative 1. So we have 2 times the derivative of x squared, that will be twice of x, minus 0 plus 10 times the derivative of x, which is 1, minus 5 times the derivative of x raised to the power of negative 1. So we have negative x raised to the power of negative 1 minus 1. So we have 2 times 2x, which is 4x plus 10. Negative 5 times negative will give us a positive. So we have 5 times x raised to the power of negative 2. So this is the derivative of a given function. Let's move on to the next question. So we need to find the derivative of the cosine of x plus a. So let us begin by first expanding cosine of x plus a. So that will give us cosine of x plus cosine of a minus sine of x times sine of a. Now we're going to apply the derivative. So we have d over dx of cosine of x plus a. So that is equals to the derivative of cosine of x minus cosine of a minus sine of x times sine of a. Now here a is a constant, so that means cosine of a is also going to be a constant. So we take it out of the derivative. So the first term will be cosine of a times the derivative of cosine of x. Similarly, sine of a is also a constant. So we have sine of a multiplied to the derivative of sine function. So that is going to give us cosine of a. So the derivative of the cosine function is negative sine of x minus sine of a times derivative of the sine function, which is cosine of x. So we finally get negative sine of x times cosine of a minus cosine of x times sine of a. Now what we're going to do here is we're going to take negative 1 as the common factor. So this negative will become a positive. Now we have sine of x times cosine of a plus cosine of x times sine of a. So this is an identity which is equals to negative sine of x plus a. So this is the derivative of cosine of x plus a, which is negative sine of x plus a. Let's move on to the next one. So here we have the function cosine of x minus 2 over sine x. So we need to find its derivative, but before that we are going to expand the numerator. So we have cosine of x minus 2. On expanding it, we will have cosine of x times cosine of 2 plus sine of x times sine of 2 divided by sine of x. So now we're going to divide each term in the numerator by sine of x. So we have cosine of x over sine of x times cosine of 2 plus sine of x over sine of x times cosine sine of 2. Now cosine x over sine of x is simply the cotangent function. So we have cotangent of x times cosine of 2 plus sine x will get cancelled out. We're left with sine of 2. So now we are going to find out the derivative. So the derivative of cosine of x minus 2 over sine x is simply the derivative of cotangent of x times cosine of 2 plus sine of 2. So we're going to apply the derivative to each term. So cosine of 2 being a constant, we have taken it out of the derivative. So we have d dx of cotangent of x plus the derivative of the constant function, which is sine of 2. This will be equals to cosine of 2. Now the derivative of the cotangent function is negative cosec squared x, and the derivative of sine 2 is going to be equals to 0. So this is the derivative of a given function.